Hello everyone, good evening. Let me check. So, am I audible? Just let me know in the chat. So, I hope I am audible and we are live now. So, today we will look at a few interview problems from lead code. So, this will be mainly a problem solving session on binary tree. So, I will just discuss a few problems, two or three problems as time permits, and then so let me check if so everything is working right. Okay, so I hope everything is working. So if you have any doubts while we are solving the problem, you can write in the chat. I'll be monitoring the chat from my mobile. Okay, so welcome everyone, welcome to this session. So let's start with the first problem for today. So the first problem is this one: invert a binary tree. So this is a very popular problem. Like, I guess most of you know about this problem, how to invert a binary tree. But today we are going to solve this problem, and this is asked in interviews quite sometimes. So the problem is this: we are given a binary tree like this, and we need to invert this binary tree. So inverting a tree means to inverting all the left and right child of the tree. So look at this. So this 2 was the left child here, and it is just like a mirror image, just like a mirror image of this tree. If you put a mirror along this line in the middle, you will just get this tree. So this is the tree, and I have to print this tree. Another example, we have this tree, and the mirror image of this tree will be this tree. So we need to invert. This is called inverting a tree, and this is a binary tree. So today we are going to solve this problem. So you can chat, you can tell me if the problem is clear, and if you have any approach in mind, you can go ahead. So let's see this. So if we have some tree like this, something like this, like 5 here. So if we invert this binary tree, we are going to create a tree like this. So this is called inverting a binary tree. So how do you think we can do this inverting of this binary tree? So if you see, inverting a tree is nothing but inverting both its left and right child. So this 2 was the left child here and 3 was the right child. Okay, and here you see that 2 is the right child and 3 has become the left child. Also look at this node 1. 1 was the left child here and 7 was the right child, and here see 7 has now become the left child and 1 has become the right child. Okay, so this is how the inversion takes place, like inverting all the left child and right child. So if we have a node, just a single node, then the inverting is nothing but just that single node, no issues. But if we have something like this, suppose we have a node and here it is 1 and here it is 2 say, then inverting is nothing but swapping the left and the right child. So you can just swap these two left and right child. 2 will become the left child now and 1 will become the right child. This is just inverting of the tree. Okay, and if we do this recursively, like for every node starting from the root, if we do this process, basically we will invert the entire tree. So let's see how we are going to do this. So we have this tree, we will do this recursively and I will try to explain it to you how we are doing this step by step. So to invert this tree, let's try to understand how we are going to do this, the algorithm, how we are going to do this, solve this problem. So if we have this tree, our current concern, we are starting from this node, the root node of our tree. Okay, so our current concern is we have to first make this, find the inverse of the left subtree of this root. So finding the inverse of left subtree here, now we are concerned with just this portion. Okay, so inverting this portion is like, if we are try to invert this, here there are just 3 nodes, like it is null, so it is just like you will make 1 the right child now. So you inverted this node. Now before going to 7, what we will do, you are now concerned with this right child. So inverting this portion means you go to this node, invert this, invert the left and the right child. Now it is the turn to invert the entire tree. Now you come here. Now to invert this tree is nothing but you will swap this, with the left child and swap this with the right child. So now the tree will look something like, if you swap the entire tree, so yeah, so it will look like this. So you just swap them. We have already swapped this 6 and 5 here, and so this is how we can invert a binary tree, just swapping the nodes along the process in a recursive manner. So if you have any doubt, you can tell in the comment, otherwise let's look at the solution, how we'll do it in code. So if you have some doubt, you can tell me in the comment. There is some lag in YouTube, I can see. No issues, I will wait for a minute. If you have any doubt, you can tell me. Okay, so I think there is no doubt from you guys, so I will just try to explain in the solution now. So here we are given the root node of the tree, and if it is null, the root is null, just simply return that root, that means null. Otherwise, the procedure we saw, we first want to invert the left subtree and then the right subtree. So we first call this function recursively on the left subtree of the root node, and then again we call this function on the right subtree of this node. Okay, so after we invert the left subtree and right subtree, then what we will do, we will swap the left and right pointers. So the left and right pointers, we will just swap them, and then we will simply return the root after swapping the left and right pointers. So this is how we can invert a binary tree, a famous interview problem, but it is pretty simple to solve. So if you have any doubts, you can tell me now. This is the base case for the recursion here, and this is the procedure. I will do this. So if this is clear, then we'll go to our next problem for today. So let's look at the next problem. If you have any doubt, you can tell me. I am looking at the comment. I am following the comment. So in this problem, we are given a root of the binary tree, and we have to return the sum of all left leaves. Left leaf means the leaves which are left child of a node. So if we have this tree, our left leaf will be this node 9, because this is in the left side, and 15 is also a left leaf, but 7 is a right leaf because it is a right node. So the sum here will be 9 plus 15 equals to 25, equals 24. That is the sum of a left leaf. In this, there is just no leaf, just one root node, so it is neither a left or right child, so the answer will be simply 0. So given this tree, we want to find the sum of all the left leaves. So how do you think we will do this? So let's say we have some tree like this. Let's say we have a tree like this, and now the left leaves will be, this will be a left leaf, this 9 and this 6. So the sum will be 9 plus 6 equals to 15. So this is what we want. We don't want to add up this node because it is a right leaf. So how do you think we can solve this problem? You can write in the comment also if you have any approach. I am following the comment. Okay, I will just give you a minute to think about it, how we can solve this, and then we'll proceed with the solution about this. So how do you think we'll distinguish between the left and the right leaves? So if we are currently at this node, how do you think we'll know if that is a left leaf or a right leaf? If we are at this node, how do you think we'll know it is a left leaf or a right leaf? So we should be able to know when we are currently standing at a node, we should be able to know if that is a left leaf or a right leaf. If we can do that somehow, then our job is done. So what do you think we can do? Any idea you have? You can write in the chat. Okay, so the basic idea we'll follow here is that for every node we'll try to put an index on that node, try to maintain a direction for that. So for the root, since the root is in the center, we'll say that it has a value 0. Now when we'll recursively call, like we recursively call the left child and the right child, like we do in like any tree traversal algorithm, like in order or pre-order. So we'll call, whenever we'll call the algorithm recursively on this left child and this right child, what we'll do, since this is a left child, we will pass this value -1 at this point, and since this is a right child, we'll call this value, we'll pass this value 1 here. So this is the only way we'll be able to know that if the current node is a left child or a right child. Now when we pass this, call this function below, what we'll do, since it is a 9 is a left child, we'll call -1 here, and there is nothing here, right? This is just null, so we'll just leave it, and here we'll call -1 and here we'll call 1. So for all the leaf nodes where we have -1, so for this leaf node, this is a leaf node and it has got -1. This is a leaf node and it has got -1 value, but this is a leaf node and it has got 1 value, so we don't consider this. So all these leaves where there is -1, we simply add the values here and we get our resulting value. So this is the way we are going to follow, and like this way we can find the sum of all the left leaf nodes. So I hope the solution is clear. If you have some doubt, you can write in the comment, and if the solution is clear, like how we are implementing this, I will just show you the code that will make it better, like you will be able to understand everything. So given this tree node structure, it has a value and a left child and right child, left and right pointers. So we have to implement this function sum of leaves, where we are given the root node. To solve this problem, we will define a function of our own called find sum, and we will pass the root here. As you saw, we are passing a value 0 for the root, so we will pass the root here with a value of 0. Okay, and let's look at this function now. This function is taking the root, like taking a node and also a value. If it is a null pointer, then just return 0 because it is just null pointer. Otherwise, you see that if it is a leaf node has a left and right pointer as null, right? So both the left and right pointers will be null for a leaf node. That is how we know. So if root left equals to null and root right equals to null, then what we'll do, we'll look at the direction, like this value we are passing in from the parent of this node. So we are passing a value from the parent, right? So if that value is -1, then we'll know that this is a left leaf. So I've already checked that this is a leaf, and after that we'll check that it is a left leaf or not. If it is a left leaf, just return the value of that node. Otherwise, this case means that direction equals to 1. That means it is a right leaf. Then simply return 0 because we are not concerned about that node. Okay, and then if it is not a leaf node, then we will simply call the function recursively on the left subtree and right subtree, and simply return the sum of these two. Simply return the sum of the left subtree and the right subtree. So this is the way we can find the sum of just the left leaves in a tree. So if you have any doubt, you can tell me in comment. So what I can do, I can just share the links of the problems we are solving in chat, so that it can be useful for you. You can find these problems later and solve them. If you have any doubt, you can tell me. I am following the chat. Okay, so after this, we will look at one more problem for today. So we'll look at this problem today, the range sum of BST. So what this problem says is that we are given the root node. Okay, I will do one thing. I will just share the link for the problem in the chat. You can just look at it if you want. So we are given the root node of a binary search tree. So it is given that it's a binary search tree. It is a binary search tree. And we are given two integers, low and high. We have to return the sum of values of all nodes with a value in the range low to high. So if return, like we are given a range low to high, and you have to simply return sum of all the values in the range of low to high in this binary search tree. So if we are given a tree like this, and we are given the range as 7 and 15, so we want to find the sum of these nodes, 7, 7, 10, 15. So what is the sum? It is 32. All the rest nodes 3, 5 and 18 lie outside of our range, so we are just concerned about these nodes. Okay, so in this next example, let's look at this. So if we are given this range like 6 to 10, all the values in this range are what from this tree? Look at this: 5, 6, 7 and 10. These are the only values which lie in this range. So the sum will be how much? We can find it. It will be 23. The sum of these nodes, 6 plus 7 plus 10. Sorry, 5 doesn't lie in this range. I made a mistake. So it is in the range of 6 to 10. 6 to 10. So it is 6, 7 and 10. So it is 23. So this will be the problem. So how do you think we can solve this? Any approach? Anyone? You can write in comment. So try to make it interactive. Then it will be like, try to make it like interview. Like you are trying, like you are given this problem in interview, and you are trying to solve it. So how do you think you will approach it? Any approach you have, you can write in chat. Then it will be beneficial for you also. So let me draw it here. And 5, 15. So till then, if you have any approach, you can write in the chat. So we have this binary search tree, and we want to find the values in the range of 7 to 15. So this is our range. So yeah, any approach, guys? Or if you have any doubt, you can also tell me that if you have any doubt. Otherwise, we will look at this solution. Okay, so try to think like this. The brute force method would be, so we'll just traverse the entire tree in any in order prior traversal, whatever you want. Then traverse the entire tree, and whenever you see that the current value of the node is in that particular range, simply add that value. So the brute force is traverse the entire tree and add up the value if it falls in the range. So the time complexity for this approach would be order of n, right? So if you have n nodes, but you want to do something better. Suppose uh, there are mm, k nodes. Suppose there are k nodes in the tree in in this range of 7 to 15. Suppose there are k nodes in our tree. So we don't want to take O of n time. We want to do something better. We want to do something maybe like in the order of the number of nodes present in this tree. So if we have just like 2 nodes in this range and like 1000 nodes in this tree, why take why traverse the entire tree? So we want to do it fast. So how can you do that? So one idea can be, you can check. So when you are traversing the tree, if you are currently at this node, look at this node. This node lies in our given range, right? 7 to 15. So we have to add up this value. And since it lies in the given range, you have to check the left subtree and the right subtree, both of them. Now you go to the left subtree. You are currently standing at this node 5. So if you are standing at this node 5, let's say, now you see that 5 is outside the range. 5 is actually less than 7. So you know that all the values like which will be in this range will be lying in the right subtree of 5. So you can simply ignore checking the left subtree. You just don't check the left subtree, because you know that all the values in a binary search tree in the left subtree will be less than 5. So you can just ignore that. So we'll simply go to the right subtree from here. Now you check that this node 7 is in the range of 7 to 15. So you can add this node here. Now after you finish this, you return to this root node, and from there you go to this right child. Now you see that 15 is in the range 7 to 15. So you add up this node 15 here, and since it is in this range, all the nodes in this left subtree can be, like if there was something here, can be in this range. So you will visit this left subtree, but you know that all the nodes in this right subtree will be greater than 15, and that is not required for us. So all this value will be larger than 15. So you can simply ignore checking the right subtree. So in this way we can prune some of the subtrees and ignore like others. So this will be efficient than like traversing the entire tree, right? So we are just traversing. So if you are considering this subtree, we will just be looking at these nodes. So we will completely ignore these 2 nodes in this tree. So this approach makes the solution better. So let's analyze what will be the time complexity for this. So the time complexity for this efficient approach So if you have any doubt, you can write in the comment. If you have any doubt till this point, the solution is clear, right? If it is clear, you can write something in chat. If the solution is clear, you can write that it is clear. You have understood it. So the time complexity here would be like in a binary search tree, we have to just go to the first node in this range, first node which is the less than this. And in binary search tree, if it is balanced, otherwise, so let's say if the height of the tree is h, if the height of this tree is h, so first trying to go finding the first value which will be in this range, that would take order of h, because they are just traversing the entire tree from top to bottom. So first we have to find this node, right? First we have to find this node, and then we are traversing all these nodes which are in this range, in the range of this. So we already saw that there are k nodes. So if we traverse these k nodes, and ultimately when we reach here, the final node in this range, we will just end it. So the time complexity here would be O of h plus k. H because of the height of this tree. We have to find the first node in this range, and then you have to look at all the k nodes which are in the given range. So this is obviously better than O of n, right? Than traversing all the nodes. So let's look at the code quickly and let's see. So we are given this root node and two values, low and high. So what we do? We first check if the root is null, simply return 0. Like that is a null node. Otherwise, if the root value is less than low, that means all the values will lie in the right subtree, right? Then you will simply write this function on the right subtree with this given range, low and high. Otherwise, if the root value is greater than high, then all the values will lie in the left subtree. So we will check the left subtree with the given values. Otherwise, what you do, you simply return the value of this node and like add this value, because that is greater than equals to low and less than equals to high, right? That is the case. That's why you sum this value and also find the sum of values in the left and right subtree. So this is a very simple implementation of the idea we just saw, and this is obviously better than O of n complexity. Like it will depend on the number of nodes which are in this tree in the given range of low to high. So I hope the solution is clear. I hope this session was useful. So before we end today, so I will just like to tell you about some of the courses that are going on in Unacademy, and if you are preparing for interviews, this will be useful. So there are currently system design courses going on backend and full stack development. So if you want, you can just look at the website and look at the syllabus. I will just give you a brief details. So all these courses will start from the next week. If you want to register for them, you can go to the website unacademy.com and check out the courses. And the registration fees here is for 6 months is it is 27k, and 12 months is 33k, and you can use my referral code to get a 10% discount. So if you are like preparing for interviews, this can be very helpful. Like all system design courses are asked. So these are some syllabuses here which will cover. So okay, let's end this session today. This is a short problem solving session. and I hope it was useful. I hope you learned something. Thank you.